Okay, so here we have another integral, and you'll notice this one, again, we have a discontinuity at -1. It's going to make our function have division by 0. We want to know, is the area between this curve and the x-axis from -1 to 2, is that going to be finite or infinite? Is it going to be convergent or divergent? So let's just picture again what we're looking at. This is our curve, x over x plus 1 squared, and we want to look at the area between this curve and the x-axis. So actually we have sort of two different regions here. Let's look at them separately quickly. This one, the positive region above the x-axis, there's not going to be any issue with this. We have our function is continuous. That region, that area is definitely finite. It's this region over here near x equal to -1 that's the issue. That's where we have our vertical asymptote. That's where we're going to have to use a limit in our integral. So let's go and figure out, is this area here going to be finite? Is it going to be infinite? So the first thing, we have to stay away again from -1. So we can introduce our parameter. And t here is going to be approaching -1 from the right. So this one, you will notice, is going to be a little bit more difficult than the last one, mostly due to the way the limit's going to work out, okay, after we've done the integral. But first we need to actually figure out a way to integrate this. Can we simplify it? It's degree 1 divided by degree 2, so we can't do anything like long division. Technically you could split this up using partial fractions, okay? However, there's also a nicer way of doing it, and here I'll give you a moment to think about it, okay, if you want to pause the video. So the other way that we could do it is actually just with a regular substitution. It's not going to work out perfectly, but it will definitely give us an easier integral to work with. If u is equal to x plus 1, du will be equal to dx, and so going back to our integral, we end up with a limit as t approaches -1 from the right. Limits of integration, we could still leave them in terms of x like we did in the last one. X is equal to 2, x is equal to t, x is equal to 2. But what happens inside? So first off, in the denominator, x plus 1 all squared, that's going to just become nicely u squared. So what happens in the numerator? In the numerator we just have this x term left over, so we have to go here and figure out what is x equal to in terms of u. Well, if u is equal to x plus 1, then x is going to be equal to u minus 1. And so we are able to finish off that substitution. Now we have the integral u minus 1 over u squared, which doesn't look much nicer than it did before, except that there's one huge difference. This one, u minus 1 over u squared, we can separate this. Okay, we could split this up into two different integrals. And what I mean by that is that the first integral still going to be from x equals t to x equals 2, but it's going to be u divided by u squared. It's just going to be 1 over u du. The second integral is going to be still x equal t to x equals 2. It's going to be 1 over u squared, and so we integrate these both on their own. The first one, and one thing I want to make sure here, let's fix, t is approaching -1 from the right, so I can't forget to carry that forward. T should be approaching -1 from the right. And then when I look at our integrals, we have 1 over u. The antiderivative there is going to be ln absolute value of u, and that's going to be the first antiderivative. The second one over here, we do the antiderivative, we get minus minus 1 over u. And this whole thing, we have the same limits of integration, x equals t to x equals 2. And now in order to deal with this, let's actually just go back from u to x, remembering that u was equal to x plus 1. So we have limit as t goes to minus 1 from the right. We have ln of x plus 1. This is going to be here a double negative, so it'll be just plus 1 over x plus 1. And now it's going to be from t to 2. So fine, let's plug it all in. Use FDC2. And this is where things start to get a little bit more complicated. So the first part, no issue, we have ln of 3 minus 1 over 3 plus 1 over 3. And then we're going to be subtracting what we get when we plug in t. So we have ln of t plus 1, and this whole thing is going to be subtracted, plus 1 over t plus 1. And so this is the integral, or sorry, this is the limit that we're going to need to do.